Hello, calculus scholars. Mr. Benzel here. Um, man, it's for a wild ride, on election night here. But anyway, we're going to be talking about taking that chain rule up to the next level with some trig derivatives. So last week, a few students asked me in class, why do we go through this exercise of computing derivatives and using these rules? Well, in the real world, things like the trig functions and exponential functions are pretty commonly seen. So in particular, some of the ones that we're really going to focus on this problem set are knowing the derivatives of sine and cosine of x. Also, the e to the x and the ln of x will be useful for later on. But I would make sure that you have all these derivatives copied down so that you can refer to these as we kind of get to those more advanced derivatives. But particularly ones that you want to really feel comfortable with, especially are the sine and the cosine of x, and the e to the x and the ln of x. Okay, let's actually get started with the basic trig derivatives. So trig derivatives nicely lend themselves to chain rule, believe it or not. So when we say sine of 3x, the 3x is the giveaway for our u. That means our du is equal to 3. So if I'm doing the sine of u, like let's say that's my function y, the derivative then would be cosine of u du. So then I just substitute in. So I got cosine of 3x times 3. And the convention is that we put that 3 in front of a cosine 3x. What you'll kind of notice, though, is that there'll be, a lot of patterns that you'll notice where that coefficient, will kind of be pulled out from a 3. Now, for this one, this is pretty quick and easy. So I could actually rewrite this as 5 d dx sine of x. So you could actually just pull that 5 out. And you're left with 5 cosine of x. And you don't even need to do any sort of u substitution for this one. And in this one, we kind of do marry. So my u is negative 9 of x. My du is negative 9. My y is equal to 9 sine of u. And then my derivative of that would be 9 cosine of u du. So what we would get after that, I put my u in, so I got the negative 9 of x, so cosine of negative 9x, and then my du is negative 9. Negative 9 times 9 is negative 81 cosine of negative 9x. So those are some basic trig derivatives. So if I say of, sine of, that's kind of a giveaway that what I am taking the sine of, or the cosine of, is my u. So I say sine of So what comes after the of would be my u. All right, let's kind of mix and match here. We can grow up a little bit. So these are the chain rule level 3s. My advice for this one, write this as a fractional exponent. And my u is going to be 2x to the 1/2. My du is going to be 1x to the negative 1/2. And for now, I would just kind of process this. So write this as 3 sine of u, and then my derivative would be 3 cosine of u du. And then I'm just going to substitute. So I have 3 cosine of 2x to the 1/2. And then my du would just be x to the negative 1/2. And then I just kind of take inventory of my numerator and denominator. So my numerator is 3 cosine, and they like the radicals in there, so just keep the radical in there. So instead of x to the 1/2, just write that as square root of x. And then the x to the negative 1/2 just becomes x at the bottom. So you just have a square root of x. And this is as complete as you go. All right. This one, so I'm going to write my u, going to be 5x to the cubed. My du is going to be 15x squared. So my y is equal to 2 cosine of u. My derivative would be negative 2 sine of u du. Always remember, derivative of cosine is negative sine. And my sine of u, so my u is just going to be 5x cubed. And then my du is going to be 15x squared. So negative 2 times 15 is negative 30x squared. And then this would be sine of 5x squared. So the chain rule can really turn, pretty ugly looking trig derivative, and it breaks it down into a very simple trig derivative that you can do. And then you kind of worry about the u stuff that's inside of a trig function. You take the derivative of it, and then you're good to go. All righty, let's look at another example or two. Let's do a chain rule level 4. So this one, we're kind of really building our rigor up here. It looks mean, but it actually really isn't that bad. So it's actually a chain rule within a chain rule. So what's going on here is I'm going to put the square root of 5 plus x. I'm going to rewrite that a little bit. So I'm just going to write that as 5 plus x to the 1/2. So this is kind of like a chain rule within a chain rule. So the du would be 1/2 times 5 plus x to the negative 1/2. And then the derivative of the inside stuff is just 1. But we, believe it or not, we got all the information we need. So my f of x is just going to be 3 sine of u. And then my f prime of x will be 3 cosine of u du. I substitute in what I need. So I have the cosine of u, which is 5 plus x to the 1/2. And then my du is going to be 1, or the 1/2 times 5 plus x to the negative 1/2. And I'm just going to take inventory. So the 3 cosine goes in the numerator. Now we'll just call this 5 plus x square rooted. And then I have a 1/2, so the 2 goes in the denominator. and the 5 plus x square rooted goes in the denominator as well. So that's probably about as hard of a chain rule as you're going to get. I call it the meta chain rule because you have a chain rule within a chain rule. So anyways, we're going to get some practice tomorrow of just a basic chain rule. But then we're going to kind of build in this video. And for the next problem set, you'll kind of go up in the ante a little bit with the chain rule. So thank you very much for checking in.